Alright, welcome back to my class. In this video, we are asked to solve this mathematical modeling question, biomathematics, so that provide a full equilibria and stability analysis for the heat equation given by this. Okay, they now explain the parameters they have here, where B is the chemical control, and then the X is the muscle fiber. Okay, now anytime we are asked to find stability and equilibria, there are two things that should come to your mind. For equilibria, the derivative of t must be 0 at equilibria. Listen, at equilibria, the derivative of t must be what? 0. Then for stability, we are going to use Jacobian. Okay, Jacobian matrix. So note this: anytime you are being asked to find equilibria in biomathematics, you remember that the derivative. So we'll tell them solution. The solution here is that we'll tell them that at equilibria, that the derivatives of t is 0. Okay, so that means that this is going to be 0 and this is going to be 0. So we have that epsilon dx dt is equal to what? 0. And we're going to have that db dt is equal to 0. So if we put 0 here, we're going to have that minus into x squared minus tx plus b is equal to what? 0. So in this case, if you equate this to 0, you make b subject of the formula, and then you equate this one to 0 and make x subject of the formula, this x. There is b in the second equation, so we are making b subject of the formula from the first equation. So there is x in the derivative of the first equation, so that's what we are making subject of the formula here. So let's make b subject of the formula. We're going to have that this time this will give us minus x squared plus tx minus b is equal to 0. So therefore, this one moving to this side, we have that minus x squared plus tx is equal to b. So therefore, our b will now be just tx minus x squared. Equation, I can call it equation 1. This is one of the answer. Very simple. So the other one is to make this one equal to 0, because this is equal to 0. So we'll say that what? X minus x naught plus x naught minus x1 u is equal to 0. So we're going to make x subject of the formula in this case. So that means this people is moving to this side. So I'm having that x minus x naught will now be equal to minus into x naught minus x1 u. Okay, so this one moving to this side, I'm going to have that my x will now be equal to what? X naught minus into x naught minus x1 u. Now this cannot just subtract this because of the u at the back here. So your equation 2. So you tell them at equilibria that b is equal to this and x is equal to this. Very, very simple. So the next thing we're going to find is now the stability. Immediately they ask you to find the stability, the first that should come to your mind is using Jacobian. To use Jacobian. So for us to use Jacobian, we'll tell them that, so we want to find stability. So to find stability, we are going to use Jacobian. So we'll say that J is equal to, now let me tell you how to fix your Jacobian matrix. Okay, first of all, you fix in column before you fix in row. Please fix in column before you fix in row. So let us fix in column before we fix in row. Now to fix in column, we're going to have what are we going to have? This is x here. Let's start from the first one. This is x. So I'm going to have partial x, partial x, column. We now come to b now. We'll have what? Partial b, partial b. Okay? Then the next thing now is carry this your dx dt and put in what? In roll. Carry it and put in roll. So I'm going to have that here will now be what? In bracket of dx dt. dx dt. So for this side, I'm going to have what? db dt. Here I'm going to have what? db dt. Okay, so don't forget this. So always arrange in column before you arrange in row. So that is it. So now if you look at this, you see that our to make the S subject of the formula, I'm going to have that this epsilon will come here, and my board is too small. That is why I'm writing this like this. I'm going to have minus 1 over epsilon here to make the S dt subject of the formula. I'm going to have epsilon here. So that means our J will now be equal to, now, this is now, we are differentiating this with respect to x, and this is equal to this. That means we're differentiating everything here with respect to x. So to differentiate everything here with respect to x, I'm going to have that this is, let me have my this thing right. I'm going to have that this is 3 over minus 3 over epsilon s squared. Okay? So because if I use this to clear the bracket, I'm going to have x cubed over epsilon minus, then plus, so there is epsilon everywhere, plus t over epsilon x, then minus b over epsilon. So if I'm differentiating the first one, differentiation said we should multiply by the power and remove one from the power. So I'm going to have minus 3x squared over what? Epsilon for this side. Then for this side, I'm going to have just plus t over epsilon. Okay, so that is what I have for that side. So the next one we're going to have is for the other side. This side said we're differentiating this thing again with respect to b. So we're differentiating everything here with respect to b. So that means there is no b here, this one is 0. There is no b here, this one is 0. There is b here, so my answer here is just differentiation of b is 1. So I'm having minus 1 over epsilon. So for this side is what? Minus 1 over epsilon. Okay? So now, for this side means we're differentiating the second equation. This thing is the second equation with respect to x. So this is the second equation. We're differentiating it with respect to x. So there is x here. Differentiation of x here is just 1. Every other thing does not have x. All this one is a s naught, s1. It's not just x. Okay, so this is 0. Everything here is 0. So differentiation of x is 1. So that means I'm having 1 here. Then finally, we are differentiating the second equation with respect to b. Okay, so that means this thing is very simple. So differentiate the rows. The first equation, okay, yes, in the first equation, in fact, even if you did not write this, look at how to do it. It's very easy. Differentiate the first equation with respect to x, then differentiate it with respect to b. You write your rule. You come to your column. You now your first rule. For your second rule is now for the second equation. Differentiate it with respect to x again, and differentiate it with respect to b. Even if you did not write this, you understand? That is the shortcut. So differentiate the first equation with respect to x, you get this. Differentiate it with respect to b, you get this one. You now go to the second equation, which is the second line. In the second equation, differentiate it with respect to x, you get this. Differentiate it with respect to b, and there is no b here at all. So I'm getting 0. Are you getting that now? So the next thing we're going to find is the engine value. Let us get the engine value. So to get the engine value, you know that the formula is now that what? J minus what? Lambda, the identity matrix. J minus lambda identity matrix. Now, instead of doing it one after the other, it will take your time. Just the easiest answer is simply to put lambda in the diagonal, to put minus lambda in the diagonal. So I'm going to have minus 3x squared over epsilon minus plus t over epsilon minus lambda. So here remain the same, minus 1 over epsilon. So here becomes 1. Here becomes 0 minus epsilon, which will give you just minus epsilon. So the next thing we're going to do is to find the what? The determinant of this. So permit me to clean here. To find the determinant of this, you know that determinant of 2 by 2 matrix is just left minus right, cross multiply left minus right. So the determinant of J minus lambda identity matrix will now be equal to, this time this will give us, this time this one will give us 3x squared over epsilon lambda. This one time this one will give us plus, okay, let us have that these people are together. You understand? So let us have that these people are together. So let me rewrite this thing to be, oh god, okay, let me write this thing to be minus 1 over epsilon in bracket of 3x squared. It will be better for me, 3x squared minus t. Then, okay, so that it will now look like this. So it will now look like minus 1 over epsilon into 3x squared minus t, then minus lambda. So this times this will give us minus 1 over epsilon into 3x squared minus t squared lambda. Then this time this will give us minus lambda squared. Okay? And that is cross multiply. So minus, then this time this will give us minus 1 over epsilon. So left minus right. So finally, I'm going to have that this is, let me start with t squared. So this is going to give us, let's see what we are going to have. Okay, sorry. Minus times this will make it a plus because there is minus here. Minus times here will make it plus, and minus times this one will still make it a plus. Okay, so I'm going to have my quadratic equation lambda squared plus 1 over epsilon into 3x squared minus t squared lambda. Then I'm going to have minus minus give up plus 1 over epsilon. Okay, so that is my quadratic equation. That is the determinant. So the next thing we are going to do, immediately you get the quadratic equation. So now let us compare it with the normal quadratic formula. But before that, we say it's equal to 0. Sorry. You know that the determinant will always equate it to 0 so that we can find our lambda, which is the eigenvalue. So to find the lambda here, we'll say that, okay, see that to remove this epsilon from the denominator, we will multiply everybody by epsilon to have that what? Epsilon lambda squared plus 3x squared minus t squared lambda, then plus 1 is equal to 0. So multiplying everybody by epsilon. So the next thing you should remember is that now, so this is the eigenvalue satisfy this. So the eigenvalue satisfy this. So the next thing we are going to check is what? The stability condition. Remember that we are checking the stability. So in the stability condition, the normal quadratic equation is going to be a lambda squared plus b lambda, then plus c is equal to 0. Okay? And then if you note here, you will see that they told us that epsilon is 0. So our a, which is equal to epsilon, they say that is positive. They say that it's greater than 0 from the question. Go and check the question. See that they say that this is positive. And if you look at this one, you see that our C, which is equal to 1, is still positive again. Is still positive. So therefore, this one is going to be positive according to one man's theorem. Let me remember his name again. What's the name of this guy? So you can check the name of the guy and then tell us in the comment section. I've forgotten the name of that man that proposed that. Okay. So from this one, our b, which is equal to what? 3x squared minus t squared. Okay. Is that t squared or just t? Where did I get t squared from? Sorry, it's t, not t squared. Please. That's a mistake. It's t, not t squared. So 3x squared minus t will now be equally greater than 0. So if we have this now, we will now have that solve for x here, and that is your answer. So for us to solve for x here, we will see that 3x squared minus t is greater than 0. So therefore, 3x squared will be greater than t. So our x squared will be greater than t over 3. Then our x, the absolute value of x, will now be greater than the square root of t over 3. So now we'll tell them that if you immediately you get this, you now conclude. And the conclusion is that the equilibrium is stable if this is greater than this. That is the conclusion. Write the conclusion for them. That the equilibrium is stable if this is greater than this. Otherwise, it is not stable. Very simple. That the equilibrium is stable if this is greater than this. Otherwise, it is not stable. So that is that for this question. So thank you very much for watching. Please don't forget to like our video, comment, and share to your friends. Bye-bye.